titans that roamed the earth, dwarfing anything alive today. What was their secret? Was there something in the air? Well, you're not far off. The answer, in large part, lies in the very air they breathed. Let's travel back in time, way back, to the Carboniferous period, about 359 to 299 million years ago. This wasn't the age of dinosaurs just yet, but it was the age of giant insects. Picture lush, swampy forests covering much of the globe. These ancient forests were incredibly efficient at photosynthesis, pumping massive amounts of oxygen into the atmosphere. How much oxygen? Scientists estimate that atmospheric oxygen levels peaked at around 35%, compared to the 21% we have today. This oxygen-rich environment was a game changer, especially for insects. You see, insects don't have lungs like we do. They breathe through a network of tiny tubes called tracheae that deliver oxygen directly to their cells. But this system has a major limitation. It's not very efficient over long distances. In today's 21% oxygen, there's a physical limit to how large an insect can get before its inner tissues start to suffocate. But back in the Carboniferous, with 35% oxygen, the air was so dense with the good stuff that it could diffuse much deeper into an insect's body. This allowed them to evolve to truly monstrous sizes. That's how you get creatures like Meganeura, the giant dragonfly, or Arthropleura, the colossal millipede. It wasn't just that they could get big. The high oxygen levels also supercharged their metabolism, giving them the energy to support their massive frames. But then, the world changed. The climate dried up, the vast swamps receded, and oxygen levels began to drop. As the oxygen thinned out, the giant insects couldn't sustain themselves anymore. Their breathing system became a liability, and they eventually died out, paving the way for smaller, more adaptable insects to take over. It's a powerful example of how the environment directly shapes the evolution of life. Now, let's fast forward to the Mesozoic era, the famous Age of Reptiles, which includes the Triassic, Jurassic, and Cretaceous periods. This is when the dinosaurs ruled the world. And when we think of dinosaurs, we think big. Argentinosaurus, for example, is estimated to have been as long as a blue whale and weighed up to 100 tons. So, was it the same oxygen story? Well, it's a bit more complicated for dinosaurs. Oxygen levels during the Mesozoic were higher than today, but they probably didn't reach the extreme highs of the Carboniferous period. They fluctuated, maybe sitting around 25 to 30%. While this definitely helped, it wasn't the only reason dinosaurs got so huge. Dinosaurs had a few other evolutionary tricks up their sleeves. One of their biggest advantages was their incredibly efficient respiratory system. Paleontologists have studied the skeletons of dinosaurs and found that they had a system of air sacs connected to their lungs, much like modern birds. When a dinosaur took a breath, air flowed not just into its lungs, but also into these sacs. When it exhaled, fresh air from the posterior sacs moved into the lungs. This means they got a dose of fresh, oxygenated air during both inhalation and exhalation. It's a one-way flow system that is far more efficient than our own bellows-like lungs, where old air mixes with new. This super efficient breathing allowed them to extract more oxygen from every breath, fueling their high metabolism and supporting their enormous bodies. These air sacs also had another amazing benefit. They made the dinosaurs lighter. The sacs invaded their vertebrae and other bones, creating hollow, honeycombed structures. Think of it like the difference between a solid steel beam and a hollow one. The hollow beam is much lighter but still incredibly strong. So a giant sauropod like Brachiosaurus wasn't a solid mass of bone and muscle. It was more like a walking, bird-like airframe, strong but relatively lightweight for its size. This solved a major biomechanical problem: how to support immense weight without your bones collapsing. Another key factor was their posture. Early reptiles and amphibians tend to have a sprawling stance, with their legs out to the side. This is not very efficient for carrying a lot of weight. Dinosaurs, however, evolved an upright stance, with their legs positioned directly beneath their bodies, like pillars supporting a roof. This skeletal structure was much better at bearing weight and allowed for more efficient movement, letting them grow to gigantic proportions. Of course, you can't get big without a lot of food. The Mesozoic world was a greenhouse planet, warmer and wetter than today, with high levels of carbon dioxide. This created a paradise for plants. Vast forests of ferns, cycads, and conifers covered the land, providing an all-you-can-eat buffet for herbivorous dinosaurs. With so much food readily available, there was an evolutionary pressure to get big. Being larger meant you could eat more, reach higher branches, and better defend yourself from predators. And this leads to an evolutionary arms race. As the plant eaters got bigger to escape predation, the meat eaters, like Tyrannosaurus rex and Giganotosaurus, also had to get bigger to be able to hunt them. A small predator can't take down a 50-ton sauropod. So, predators evolved to become larger, more powerful, with stronger jaws and bigger teeth. This cycle of bigger prey leading to bigger predators, and vice versa, pushed the limits of size for both groups. Finally, let's talk about their metabolism. For a long time, scientists thought dinosaurs were cold-blooded, like modern reptiles, slow and sluggish. But the evidence now strongly suggests that many, if not all, dinosaurs were warm-blooded, or at least had a metabolism somewhere between a reptile and a mammal. Their rapid growth rates, evidenced in their bone rings, and their active lifestyles point to a high metabolism. A warm-blooded metabolism requires a lot of energy, but it also allows for sustained activity and rapid growth. This ability to grow quickly meant they could reach enormous sizes in a relatively short amount of time, giving them a better chance of surviving to adulthood. So, the secret to the immense size of dinosaurs and ancient insects wasn't just one thing. It was a perfect storm of environmental and biological factors. For the insects, it was primarily the oxygen-rich atmosphere of the Carboniferous period. For the dinosaurs, it was a combination of factors: higher oxygen levels than today, a super-efficient bird-like respiratory system, hollow bones that made them lighter, an upright posture for better weight support, a planet teeming with plant life to fuel their growth, and a predator-prey arms race that pushed the boundaries of size. Then, about 66 million years ago, it all came to a dramatic end. A massive asteroid struck the Earth, triggering a global catastrophe. The impact threw so much dust and debris into the atmosphere that it blocked out the sun, causing plants to die and the global food chain to collapse. Being big was no longer an advantage. It was a death sentence. The giant dinosaurs couldn't find enough food to sustain themselves, and they vanished, leaving the world to the smaller, more adaptable creatures that survived. This included our distant mammalian ancestors, who, free from the reign of dinosaurs, could finally emerge from the shadows and diversify, eventually leading to us. It's a fascinating story of how our planet and the life on it are deeply interconnected. The very composition of the air and the climate of the Earth set the stage for these incredible giants to evolve, and a sudden change brought their reign to an end. It makes you wonder, what kind of creatures might evolve in the future as our planet continues to change? The story of life is always full of surprises. Thanks for joining me on this journey back in time. If you enjoyed this and want to explore more mysteries of the ancient world, make sure to like this video and subscribe to the channel. Let me know in the comments what ancient mystery you'd like me to cover next. Remy signing off. Stay safe and stay curious. See you in the next one.